Hello everyone, welcome to IIT and GATE classes, and this will be our second lecture on TOC. Okay, and in the first lecture I have explained the term what exactly TOC is, okay, what are the various areas in TOC and so on. And I have already completed the first chapter, that was the basic terms used in TOC in the first lecture itself. This will be our second lecture, and in this lecture I will be starting the second chapter of TOC. Okay, so the second chapter of TOC is finite automata and regular languages. Okay, and first I will discuss the syllabus of this chapter, and then we will jump to each and every topic of this chapter. Okay, so the syllabus is as follows. So the first topic of syllabus will be introduction to FA. In this topic I will give you brief introduction about what exactly FA is, its type, that is NFA, DFA, etc. In the second chapter, we will start construction of finite automata. In the third chapter, or you can say third topic, we will study NFA to DFA conversion algorithm. Then fourth topic will be minimization of states of DFA. Fifth will be NFA with null move. Sixth will be Millet-Moore machine. Seventh will be about grammars. Okay, and eighth topic will be Chomsky hierarchy. Ninth will be construction of grammars. 10th will be closure properties of languages. 11th will be regular expression. 12th will be equivalence of FA, regular grammars and regular expressions. And the 13th and the last topic will be pumping lemma for regular languages. Okay, so total 13 topic we have to study in this chapter. And as I have already told you, that this chapter is the biggest chapter of TOC, and almost 50% of TOC will be over when we will complete this chapter. Okay, so and obviously this is very big chapter. Now we have to study 13 topic in this chapter, and each and every topic is quite big also. Okay, so approximately I will take around 10 to 12 hours to complete this chapter. Okay, so let's move to the first topic, that is introduction to FA. Okay, see, I have already written something. So introduction to FA. So what exactly is FA? FA is finite automata. I have bifurcated the word and I have given meaning of each and every word. Finite here means finite number of states. Auto means automatic. Meta means machine. Okay, so automatic, what exactly automatic means here? See, automatic means as soon as we give input to these machines automatically start running. That is, we do not need to start these machines manually. For example, we put petrol in car and then we start the car and then it start running. But in case of automata, as soon as the input is given, it will start automatically. That is, we do not need to start these machines. Okay, and finite here means finite number of states. What exactly state means? This will be clear after some time. Okay, so let me give you a brief intuitive idea about finite automata. See, forget about finite automata. You have given a machine. Okay, so you have a machine like this. Okay, so you have a machine. Okay, and what will be the first question in your mind about the machine? The first question will be, what exactly is input to the machine? What exactly is output from the machine? For example, you buy a car, then the first question will be the first question in your mind will be what input it takes. That is, it take petrol, diesel, CNG, etc. And output is what average this car is giving me. Is it giving me 20 kilometers per liter, 30 kilometer per liter, and so on. Okay, so the first question is what is the input, second is what is the output, and the third question is what is the state of the machine. State of the machine, like if you run the car for 1000 kilometer at a stretch, then will it become hot or it will remain cool. Okay, so there can be two states of the car. Similarly here also we have many states. Okay, so I will give you a rough idea about states and so on after few slides. And you can think of state like levels. Okay, so level 1, level 2, level 3, and so on. Like this you can have intuitive idea about states. Okay, so this is a basic introduction to FA. So input is what? Input to FA is string. Okay, input to FA is string, the string which we have already studied in the previous lecture. Okay, output is what? Output is either yes or no. Yes means string is accepted by machine, and no means string is rejected by machine. Okay, what exactly accepted rejected means, that will be clear after a few slides, but I have given you basic idea. So FA need string as input, and it will give output as yes or no. Yes means string is accepted, and no means string is rejected. Okay, so fa is not producing any output string and so on, it is just giving you output as yes or no. So hence fa are also known as acceptor machines. Okay, finite automata is also known as acceptor machine. Okay, or you can say simply acceptors. Acceptors, why we are calling them as acceptor? Because output is either yes or no. Okay, I hope I have cleared this point. Okay, so now let's jump to the you can say formal definition of fa. Okay, so formal definition of fa, or you can say mathematical definition of fa, it is a five tuple. The five tuple are q sigma delta q naught f. So fa is represented by five tuple. So five tuple are, first tuple is q, then sigma delta q naught f. So q is what? Q is non-empty finite set of states. So you have to remember each and every word. I have already said you in previous lecture that definitions are very, very important in this course. So you have to remember each and every definition word by word. Okay, so q is what? First thing is, it is a set of states. But what exactly, what type of set is this? This set is non-empty as well as finite. Okay, next is sigma, that is input alphabet. Input alphabet we have already studied in the previous class. Okay, so sigma can be say a comma b, or sigma can be 0 comma 1 dot 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 dot. We have already studied all these things. Okay, delta. So I will move to next slide, then I will show you about delta. So q naught is initial state, f is finite set of final states. So f is what? Set of final states, and it is also finite. Okay, let me give you one more thing. So f will be obviously a subset of q. Q is what? All set of all the states in f is q, and f is set of final states in q, set of final states in fa. Okay, so q is set of all states in fa, and f is set of final states in that fa. So if we have say 10 states, then we can make 1 2 3 up to 10 states as final also. Okay, so in the set of states, we will take some states as final also. Okay, and I have not used the word non-empty. So f, or you can say set of final states, can be empty also. Okay, so that's why I was saying you have to remember each and everything word by word, otherwise you will make mistake in exam. Okay, so q must be non-empty. Okay, and f can be empty also. Okay, so f can be empty also, it can be empty also, but q, as I have already said, it must be non-empty. And q naught is what? Initial state. Okay, so q naught will also belong to q. Okay, I hope I have made the point clear to all of you. Okay, so these are five tuple. And what about my delta? Let's move to next slide, we will get idea about delta. Okay, so let me give you a brief introduction. See, I have already told in the previous slide that input to FA is string. So where exactly this string will be stored? Okay, since you are giving input as string, so this input must be stored somewhere. Like you put petrol in your car, then there is a tank in the car which store the petrol. So similarly, here in FA also, you are giving input as string, so this input must be stored. Okay, so this input is stored on a tape of infinite length. Remember all these things. See, I am using the word infinite length tape. Infinite length tape. Okay, so but the string is always of finite length. I have already told you about this in the previous class. So string is of finite length only. So then why I am taking infinite length tape? See, no doubt each and every string is of finite length, but if you take the finite length tape, say you take tape of say 100 cells. Okay, let me give you some idea. You take a tape of 100 cells, then you can store only 100 symbol in it. So directly indirectly I am saying that string cannot be more than 100 length. This is not the case. We can give string of any length. So hence to accommodate that string properly, we have taken tape as of infinite length. Okay, we cannot take tape as finite length, because if we take tape as finite length, then obviously it can store then we will have a limit on the length of string, but there is no limit on length of string. We can give any length string as input to FA. Okay, hence we have to take infinite length tape. Okay, so let's move forward. So this tape is of infinite length, which is divided into cells. Okay, each cell store one symbol at a time. Okay, like say sigma is a comma b, so we will store either a or b in each cell. So here we have stored a b b a b b a b dot 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 dot, like this. Okay, so FA consists of tape of infinite length divided into cells, each cell store one symbol at a time. We have a read head. Okay, we have a read head. One end of read head is connected to the tape, while another end is connected to finite state control mechanism, which store the state of the machine, or you can say current state of the machine. Okay, so this is a read head. Okay, so read head is position, it is automatically positioned to the first symbol of the string, or you can say first symbol of the input. Okay, so read head is automatically positioned to first symbol of the string or input, and one end of the read head is connected to tape, while another end is connected to FSCM. This is known as FSCM, or finite state control mechanism. Finite state control mechanism. Finite state control mechanism, or FSCM. Okay, and FSCM store the current state of machine. Store current state of machine. Store current state of machine. Okay, so read head, one end of the read head is connected to tape, while other end is connected to finite state control mechanism, and finite state control mechanism store the current state. And initially the current state will be obviously your initial state itself. Okay, so Q0 is our initial state, and that will be stored initially in the FSCM. Okay, now the question will come that FA is at state Q0 and symbol A is read from the tape, then what will be the next state, or what will be the subsequent state on which FA will go? So this answer is given by delta. Okay, so next will be, I think you have already imagined that read head will come here because it has already read this A. So now read head will be here. Okay, and FSCM will store what? Q1, Q2, and so on, which state. So this answer is given by delta. Okay, so if we have a move like this, so let me give you one example of delta, then you will get a good idea. Say I will write like this: Q0 comma A is equal to Q1. So this means FA is at state Q0, symbol A is read from the tape, then it will move to state Q1. So now next state will be Q1 here. Now we will say FA is at Q1, it has read symbol A, then on which state it will go? So that will be again given by delta, that is say Q1 comma A, that will be say Q2. So now we will move to this symbol B, read head will be on this B, and state will be Q2. Okay, now at Q2 B is read, which state it will go, and so on. So this is a basic introduction to delta. So what can I say? What exactly is delta? See, delta is a function. Okay, let me say you like this. Okay, let me move slide. Okay, now delta is what? Delta is a function. Delta is a function. Okay, so it is a function from which delta is a function. Okay, from which, so from state and input alphabet to state. Okay, we are moving to some state now. So FA is at state Q, any state, and it has read some input symbol, then it will move to some state like this. So delta is just like a function from Q cross sigma to Q. Roughly I can say like this. Okay, so this is all about delta. I hope I have made the point clear to all of you. Okay, so now we should revise all these things first, and then we will move to next time. Okay, so FA is of 5 tuple, Q sigma delta Q naught F. Q is non-empty finite set of states. Sigma is input alphabet. Delta is, I have already told you, it is a transition function. Okay, let me give you a technical word for it. It is a transition function. Delta means transition function. Transition function. Okay. Okay. So delta is transition function. Q naught is the initial state, and F is the finite set of final states. Okay. So all these things will be more clear when we will move to certain examples of F. Okay. Okay. So now let's divide your FA into two categories or two types of FA, that is DFA and NFA. So based on this delta, that is transition function, we have divided FA into two types, DFA and NFA. DFA is deterministic finite state automata. NFA is non-deterministic finite state automata. So delta for DFA is like this, which I have already told you, that is Q cross sigma to Q. Okay, so FA is at any state Q. It has read some input symbol, then it will go to exactly one of the state. And please, I am saying it again and again, it is a function. It is a function. Okay, so since it is a function, I hope you have already studied about functions. So I can say if Q, or you can say set of states, is say Q naught comma Q1, sigma input alphabet is say A comma B. Okay, then I have to define each and everything. Okay, I cannot leave something like this. See, I will give you idea about functions also. Okay, so Q cross sigma, now we are doing cross product, Q cross sigma. So I will say Q naught comma A. I think you already know how to do cross product of two sets. So we have set one, that is Q naught comma Q1. Set two is A comma B. So Q naught A, Q naught B. Q naught B. Okay, ji, Q1A, Q1A, and then Q1B. Okay, so this will be Q cross sigma. Q cross sigma, and then Q cross sigma to Q na. So Q is Q naught Q1. Okay, so now I will define a function. So Q naught comma A to Q naught. Okay, I'm just linking all this mapping. I'm just doing a mapping. Q naught comma B is again Q naught. Q1 comma A is Q1. Q1 comma B is Q1, like this. I can define all these things like this. Okay, so Q cross sigma to Q. This is a function, that is delta for DFA. Okay, so I cannot leave anything since it is a function from Q cross sigma to Q. I cannot leave any element from Q cross sigma. See, I have mapped each and every element from Q cross sigma to Q, and mapping will be with exactly one element. So Q naught comma A can be linked with exactly one element. It cannot be linked with two or more elements. I hope you already know all these things about functions. Okay, so Q naught comma A will be linked to Q naught, Q1, Q naught comma B will be linked to Q naught, and so on. You can link with anyone, but the main thing is each and every element will be linked to exactly one element. Okay, I hope you already know all these things about functions. Now, each and every element in Q cross sigma will be linked with exactly one element of Q. Okay, I think you already know. I should not repeat all these things. It's wastage of time and so on. Okay, so this is all about DFA. What about my NFA? Delta of NFA is like this. Q cross sigma, let me use a different color. Okay, that will make slide more beautiful. Q cross sigma to 2 power Q. 2 power Q means power set of Q. Okay, so for example, and again it's also a function. No? So it's again a function. Okay, so let's take same example. Q is Q naught comma Q1. Sigma is A comma B. Okay, so now Q cross sigma will be again same, Q naught comma A, Q naught comma B, Q1 comma A, Q1 comma B. So this will be your Q cross sigma, and 2 power Q, that is power set of states, will be phi, then Q naught, then Q1, and then Q naught Q1. Okay, So this will be the power set to power q. Okay, now we since it is a function, then I will do a simple mapping. Say q naught comma a is linked with q naught, okay, with q naught, and q naught comma b is linked with phi, q1 comma a is linked with q naught q1, q1 comma b is linked with q1, and so on. Okay, I hope I have made the point clear. So q naught comma b to phi, what does this mean? This means that if NFA is at state q naught and symbol b is red, then it will go nowhere. So this is known as dead configuration. So please remember all these things, that dead configuration is allowed in NFA but not in DFA. See, in DFA I have not made this phi and so on. Okay, so each and every state and each and every input symbol combination, we should have exactly one move. That is the basic meaning of DFA, exactly one move. But in case of NFA, dead configuration is allowed. Dead configuration means whenever NFA is at state q naught and B symbol is red, then that will be a dead configuration. That means NFA will not move to any of the state. That is the basic meaning of dead configuration. Okay, and what about this case, q1 comma a to q naught q1? This means what? Whenever NFA is at state q1 and symbol a is red, then it can go to either q naught or q1. So choice is also allowed. Okay, so in case of NFA, let me write all these things. In case of NFA, choice is allowed. Okay, choice is allowed. Similarly, you can say dead configuration is also allowed. Okay, but in case of DFA, no choice, and no dead configuration. Okay, if you are able to follow all these things, then it's okay. But if you are not able to follow all these things, no need to worry. I will give you examples, lots and lots of examples. Then everything will be crystal clear to all of you. Okay, so basically, I have just given you introduction about delta of NFA and DFA. So according to delta itself, we have divided FA into two categories, that is DFA and NFA. DFA is deterministic finite state automata, NFA is non-deterministic finite state automata. And for DFA, transition function is like this, q cross sigma to q, and for NFA, it's like q cross sigma to 2 power q, that is power set of states. Okay, so it for DFA also, it's a function, it's a function or mapping. So q is this, sigma is this, then I have given an example of function like this. Okay, so q cross sigma to q, and there is no choice, no dead configuration. Choice means what? Q naught comma a, then then we should have a choice for to go to q naught or q1. But if q naught comma a go to q naught as well as q1, that means what? This won't remain a function anymore. Like this is not a function. You know all these things. Q naught comma a is mapped to q naught also and q1 also. This is not allowed. This is not a function. Okay, I think you already know all these things. Okay, but in case of NFA, this is allowed because we are going to 2 power q, power set of states. So I have linked with only one element, that is q naught comma q1. Q naught q1 a is linked to q naught comma q1. So again, this is a function itself. Okay, I hope I have made the point clear. Okay, so so choice is not allowed and there is no dead configuration. Okay, dead configuration means what? In case of DFA, if we have a dead configuration, then I can say leave this q1 comma b part. So but we cannot leave any element in q cross sigma because it's a function. Okay, so we have to give mapping for each and every element in q cross sigma. Okay, and this dead configuration, how we have shown this dead configuration? In case of NFA, we have shown the dead configuration with the help of phi. So q naught comma b is linked with phi. Okay, so linking is must. We have to map each and every element in q cross sigma to element in this. Okay, so with exactly one element in the set. This is the basic meaning of function. Okay, so I hope I have made the point clear to all of you. Okay, so here choice is also allowed and then configuration is also allowed, but in case of DFA, choice is not allowed and that configuration is also not allowed. Okay, why? Because it's a function only. Okay, so let me put everything on one slide so that you can easily note it down, all these things. And now we will move to next slide. Okay, so please note it down fast. Okay, so this is all about delta of DFA and NFA. And the next is we have two ways to represent FA. Okay, we have two ways to represent FA. One is state transition diagram and second is table method. See, these machines are imaginary machines. Okay, so or you can say abstract machines. Abstract or imaginary, but it's the same thing. Okay, so since these are imaginary machines, so there should be some way to represent these machines on your say you should be able to draw these machines now on copy pen and so on. So there are two ways to represent these machines or FA, that is state transition diagram and table method. So what is this state transition diagram? Let me give you a basic idea. Okay, so let's take like this q naught. Since q naught is the initial state, so we will apply arrow here. This is the standard notation. Q naught, then Q1, and then Q2. Okay, so final state is represented by double circle. So Q naught A like this, then A, and then A. Okay, like this. We have made a machine like this. Okay, so first thing is we should know the 5 tuple, all the 5 tuple in this machine, then we will jump to some other things. Okay, so let's do labeling. So Q, that is set of states. I think everyone can answer this. Q naught, Q1, and Q2, these are the states. Sigma, that is input alphabet, only one A. Okay, A is given, B is not given, so only A, so sigma will be A. Okay, then delta, that is transition function. Delta will be like see delta Q naught A, that will be what? Q1. Delta Q1 A, that will be Q2, and delta Q2A, that will be Q naught. Okay, so see, we have exactly one now. See, delta Q naught A, Q1, Q1A, Q2, Q2A, Q naught. Okay, so this is a DFA. This is not NFA. Rather, every DFA is NFA also. I will prove this point later on. But for now, I can say that this is a DFA. Okay, this is a DFA. Why this is a DFA? Because there is no choice and no dead configuration. Okay, so hence it is a DFA. Okay, now Q sigma delta, then Q naught. Q naught, your initial state is Q naught only, and F, that is final state, or you can say set of final state, is Q2. Since F is set, F is a set of states, so we have to apply curly brackets here. Okay, so this is your final state, that is Q2. So since I have given all the 5 tuple here, so my first notation is clear to all of you. I hope this is clear to all of you. Okay, so this is your what? State transition diagram. Okay, state transition diagram. Okay, for a DFA. Now, can you tell me what will be the table method? Table method is again very simple. Let's convert this DFA, or you can say state transition diagram, to table itself. Okay, so for table, see, we will show states in the rows Q0, Q1, Q2, and initial state with arrow and final state with a circle. Okay. Now here we will show this input, that is A. So now question will be Q0 A. So whenever FA is a state Q0 and A is read, then where it will go to Q1 state. So we will full here Q1. Q1A. Q1A is Q2. Q2A. Q2A is Q0. Okay. So this is your table method. I hope this is very simple and it's clear to all of you. Okay, so this is the for DFA, and let me show you one example of NFA also. Okay, so let me show you one example of NFA also. So let's move downward and I will show here example of NFA. Let's take the same example itself, say Q0, then A, Q1, A, Q2, Q2 was my final state, and then A here. Now let's apply self loop here. Okay, so first let me give you idea about 5 tuple. Okay, or say, see, you can copy paste all these 5 tuple here also. Okay, so Q sigma, Q0 F, all these things are same. Let me give you intro about delta here. Okay, so it's your homework. You will automatically fill Q sigma delta. I will give you delta, and then q naught, and then f. You will fill all these things. Delta I am giving you. Okay, so delta will be say delta q naught a. So at q naught, whenever a is read, then where this fa will go. Okay, at q naught, whenever a is read, where this fa will go. So it can go to either q naught or q1. So it is going to some set of states. Okay, so please do not say like at q naught, whenever a is read, then it will go to both the states. No, it won't go to both the states, q naught, q1. It will move to exactly one of the state, either q naught or q1. That is the basic meaning of choice, which I have already told you that in NFA we have a choice. Okay, okay. So next, delta q naught is q naught q1, then q1. So delta q1a, delta q1a is q2, then delta q2a is q naught. Okay, I hope I have made this point clear. This is very, very simple. You can note it down, all these things. Okay, so this is a perfect example of NFA. Why? Because we have a choice here. At q naught, we have a choice that I can go to q naught, or by reading a, I can go to q naught, or I can go to q1 also. Okay, so let me give you one more example. Okay, so I think you may get confused here. So let me give you one more example. Okay, so let's take it like this: q naught a, q1 a, q2. Okay. Tell me something about whether it is NFA or DFA. You may think that it is a DFA because we do not have any choice, but here we have a dead configuration. What about q2a? So delta q2a will be 5. Okay, so hence this will be a NFA, and it is not a DFA. It is not a DFA. This is NFA, but this is not DFA. Why this is not DFA? Because that configuration and choice, nothing is allowed in DFA, but here we are using dead configuration. Okay, okay. So this is all about your you can say basic representation of FA. Okay, yeah, and let me give you a table method also. Okay, so this is your state transition diagram. Okay, this is your state transition diagram. Okay, and let's convert it into table. So let's do it here itself. Okay, so in the rows we will write state q naught, q1, q2. Q naught will be our initial state, q2 will be our final state, and input is a only. Q naught a, q naught a will be q naught comma q1. Okay, q1 a will be q2, and q2 a will be q naught. See carefully, I am writing it in set format. Why I am writing in set format? I think you have already guessed all these things, because see, in the previous slide I have told you for NFA it's q cross sigma to 2 power q. 2 power q is power set. Power set means what? Power set is what? Set of set. Power set is, or you can say set of all subsets of set. Subsets of set. Okay, power set is set of all subsets of set. Okay, so that's why. Okay, that's why I am writing it here in set format. See carefully. Phi is also an empty set. Okay, so please, I hope you already know all these things, that phi is not equivalent to saying as phi within bracket. So this is what? This is a set which contain empty set as an element, and this is what? This is an empty set itself, that is like this. Okay, so phi is like this, and phi within bracket is, this is a set which contain empty set as an element. Okay, so please do not get confused with all these things. Okay, so yeah, so let's move here. So now I have written in set format. Okay, so we have to write in table method. Whenever we are making a table for NFA, we have to write in states in set format itself. Okay, so this is the basic idea. Whenever you get a you can say table, then as soon as you see a table, then you can directly guess whether this is for DFA or NFA. Since each and every cell is having exactly one entry, hence this is for DFA. This is the basic, you can say, mechanism to recognize whether this is a DFA or NFA. So it is a perfect example of DFA. Why? Because each and every cell exactly one entry. And similarly here each and every cell is not having exactly one entry. Here we have two entries. Here we have two entries. Okay, and in the set format we have written, so it's nothing but NFA. Okay, similarly, if you convert this, I think you have already guessed all these things. Okay, so if we convert this into the table, then what we will get? Q0, Q1, Q2. Okay, and on A, Q0A, this will be Q1, Q1A, it will be Q2, and Q2A is dead configuration. So you can write here 5, or you can leave it blank also. Okay, so if any cell of the table is blank, then again this means it is nothing but NFA. And better practice will be apply brackets here. Why? Because these are nothing but set of states. So these are very basic points which you should remember. So in place of keeping the cell blank, you can write 5 also. Okay, so if any cell has 2 or more than 2 entries, or any cell is empty, then that is the basic meaning of NFA. Okay, so simply I can simply say no choice or no dead configuration, then it will be a DFA. Or if you have a choice or dead configuration, then it will be NFA. Okay, now you should remember one thing, one basic thing, that is every DFA. Okay, let me write it properly. Every DFA, okay, every DFA is NFA, but vice versa not true. But vice versa not true. Vice versa not true. This is very, very important point, and it will keep you confusing in entire TOC subject. So please make some star on this thing. This is very, very important. Okay, so every DFA is NFA, but every NFA is not DFA. Why this is true? Because you can say DFA is a special case of NFA. Okay, we can think like this also. DFA is a special case of NFA. DFA is a special case of NFA. Okay, can you tell me why this is true? This is true because in case of DFA we have function from q cross sigma to q, but in case of NFA we have function from q cross sigma to 2 power q. So if you pick, see, if you do not pick q0, q1 or phi, that is you link each and every element of q cross sigma to either q0 or q1, that is singleton sets. Okay, singleton set na, which have cardinality 1. Okay, so this has cardinality 0, this has cardinality 2, and this has cardinality 1, this is cardinality 1. So if you link each and every element of q cross sigma to singleton set here, then obviously we will get a DFA. Okay, so hence I can easily say that definition of NFA is more general, but definition of DFA is restricted. Okay, restricted in the sense, in case of NFA, okay, so in case of q cross sigma to 2 power q, na, in case of function from q cross sigma to 2 power q, if you pick only singleton set, that is you have to link each and every element with either q0 or q1, then obviously we will get a DFA. Or simply see like this also. I have already told you all these things. See, for DFA, we have a function from q cross sigma to q, na, that is like this. So this set is included in this set or not? Obviously, this set is included in this set, and more precisely, I can say link each and every element of q cross sigma to singleton set here. That's it. Okay, so now I hope I have made the point clear. So DFA is a special case of NFA in which each and every element of q cross sigma is linked with singleton sets. That's it. Okay. Okay, so now I think you have understood this point, that every DFA is NFA, but vice versa not true. Okay, so whenever question says FA or finite automata, by default FA means NFA and not DFA. By default FA means NFA. Okay, so now consider this thing also. I have said that this is a DFA. Since I have said this is a DFA, so obviously it is NFA also. Nobody can stop me saying like this. Since this is a DFA, so this is NFA also. Okay. Okay, so I hope I have made the point clear to all of you. So let me put everything on one slide so that you can note it down, and then we will jump to next slide, next important slide. Okay, so try to note it down on a faster pace. Okay, so note it down till here, and then this also. Okay, so let me see if I can manage everything on one slide. Yes, I can manage it, so you can note down all these things. Okay, pause the video and note down all these things. Okay, let me move to next slide. So I have cleared you. I hope I have made the point crystal clear to all of you that there are two ways to represent FA: state transition diagram and table method. Okay. Next is language accepted by DFA. This term is very important, and it will be used in entire subject. So language accepted as DFA is starting from initial state. Okay, after reading entire input string. Oh, sorry, this is not language, this is string. Okay, string accepted by DFA. Okay, so this is acceptance of string by DFA. Acceptance of string by DFA. This is nothing but starting from initial state, after reading entire input string, DFA is at any one of the final state. Okay, please remember all these things. So that's why I have written this definition in 3 steps, so that you can remember each and every step. First step is starting from initial state. Second step is after reading entire input string, DFA is at any one of the final state. Okay, so let me give you some examples here. Okay, so this was our you can say DFA. So let's take string like say null. So smallest string is null. Okay, null is nothing but a power 0. You have taken nothing. Okay, so please remember this thing, that if any machine accept null, this means that initial state will be final. Initial state must be final. Now here initial state is not final, so null is not accepted. Initial state must be final. So here initial is not final, so null is not accepted. Okay, so next is single a. So after reading a, we will move to q1. So hence, but q1 is not final, so it is rejected. And please, I'm saying again, you have to start from initial state. Starting from initial state, after reading entire input string, FA must be at any one of the final state. Okay, this is the definition. Okay, double A. What about my double A? Double A will be obviously accepted. Why? Because starting from Q0, we are at Q2. Triple A. Triple A will be rejected. Why? Because after reading entire C, I cannot say after double A we are at Q2, Q2 is final, so string is accepted. No, I have used the word after reading entire input string. So after reading entire input string, that is triple A, we will be at Q0, and Q0 is not the final, so triple A is rejected. Next will be 4A's. 4A's will be accepted or not. A power 4 will be obviously rejected. You can check it out. We will be at Q1. A power 5 will be accepted. Okay, you can check it out. Okay, so next term is language accepted by DFA. Language accepted by DFA is set of all strings accepted by DFA. Set of all strings accepted by DFA is language accepted by DFA. So let me write the language. A power 2 will be accepted, then a power 5 will be accepted, then a power 8 will be accepted. You can see 3, then 6, 7, 8. Oh, sorry, a power 2 is accepted, then a power 5 now. 1, 2, 3, 4, 5 is accepted, then 6, 7, 8 is, yes, 8 is accepted, then 9, 10, 11 is accepted, a power 11 dot. Okay, so let me write this language in proper way. It will be a power 3n plus 2 such that n is greater than equal to 0. Okay, so put n is 0, then a power 2 plus 0 is a power 2. So a power 2 is accepted. Then n, when n will be 1, then a power 5. When n will be 2, then 8, and so on. When n will be 2, then 3 into 2, 6 plus 2, 8. When n will be 3, 3 to the 9, 9 plus 2, 11, and so on. Okay, I hope you have made I have made the point clear to all of you. So language will be a power 3n plus 2. Okay, how I remember all these things, or you can say how I figured out that this language will be a power 3n plus 2. See, see the pattern here. Okay, each and every language will have some pattern. Okay, you have to recognize that pattern. A power 2 is accepted, then 3 is rejected, 4, 5 is accepted, then 6, 7, then 8 is accepted, and so on. So I hope I have made the point clear that first string accepted is a power 2, then a power 5, then a power 8, and so on. Difference is 3 now. Difference is of 3. So a power 3n plus 2. Okay. Okay. So now language is nothing but set of all strings accepted by DFA. Okay. Next is acceptance of string by NFA. What do you mean by acceptance of string by NFA? See, here I have made this NFA. What will be the string accepted? String accepted means there should be at least one path which lead us to the final state. Starting from initial state, there should be at least one path which lead to final state. Okay, so so let's take examples. Null is rejected. Obviously, initial is not final. Null is rejected. Then single a is rejected. Single a is rejected. Why single a is rejected? Because after reading a, NFA can be at q0 also or q1. Okay, so if a is read, then state can be either q0 or it can be either q1. Okay, so none of them is final, so a is rejected. Double a, after reading double a, then NFA can be either at q0, it can be at q1, it can be at q2. So since it can be at q2, so double a will be accepted. Let me put it this way. If you are not able to understand double a, see all the possibilities: q0, then a, then q0, then a, and then q0. Okay, so both a's run on in q0 only. Now another possibility can be on q0 you run a, you move to q1. Okay, or you move to q0 only, and then a, you move to q1. For double a, another possibility can be a, then q1, then a, then q2. Since one of the path lead us to the final state, then the string will be accepted. Double a is accepted. Similarly, triple a is also accepted. Why? Because run one a on the self loop, then two a's will move to q2. Similarly, a power 4 will be accepted. Why? 2a will be in the self loop, then 1a with q1, and then 1a with q2. So let me put it properly. On q0, you will run 2a's. Then third a will lead to q1, then fourth a will lead to q2. So since we have one path which is leading us to q2, so a4 will be accepted. A5 again, obviously you can say it will be accepted. So the idea is like this. N minus, see, a power n, for a power n minus 2 a's you will put in q0 only, and then for second last step with q1, and for last step you will move to q2. Okay, so a5 will be accepted, and so on. So what about the language? How will you write the language accepted? Will be what? Language accepted will be L will be a power, see, pause the video and try to answer this question. This is very easy question. A power n plus 2 such that n is greater than equal to 0. Another way can be L is equal to a power n such that n is greater than equal to 2. Okay, so 2a, 3a, 4a, 5a, 6a, 7a, and so on. All these a's are accepted. Okay, I hope I have made this point clear to all of you. Okay, so let's take this language also. Language accepted by this NFA will be what? This is NFA, you know already, because here we have a dead configuration. So what will be the language accepted by this NFA? So L will be, okay, so smallest string, null is not accepted, single a is not accepted, double a is accepted. Double a is accepted. Triple a, no, triple a is rejected. Why? Because on q0, when a is read, we will move to q1. Q1 a read, we will move to q2. Q2 a, where is q2a? Please do not say that we are at q2 only, because there is no move. No, we will move to this will be a dead configuration, and dead configuration always means string is rejected. So only string that will be accepted will be double a only. Okay, so language will be only one language consists of only one string, that is AA. Okay, so this is obviously an infinite language. This is also an infinite language, but this language is this language contain only one string, that is AA. Okay, I hope I have made the point clear to all of you. Okay, so okay, so if you okay, let me repeat this thing. If you are not able to understand AAA, okay, try to run AAA on this machine. On Q0 A, it will move to Q1. Q1 A move to Q2. Now on Q2 we will read A. Where we will go? Okay, on Q2 we cannot read anything. Okay, so it will be a dead configuration. So only one string will be accepted, that is AA. Okay, okay, so now I have made the point clear that acceptance of string by NFA is there is a path from initial state. After accessing it, NFA is at any one of the final state. Okay, so language accepted by NFA will be set of all strings accepted by NFA. Okay, okay, so now let's move to next slide. Next topic according to the syllabus of your first chapter will be construction of FA. Okay, so next topic is construction of FA. So I have made some category of questions, okay, and we will try to solve all these questions. So first question is ending with something, ending with something. Okay, first category is ending with something. So I have already written a question, and that construct an FA which accepts all those strings over A and B which ends with A. This is very simple question. Since we have used the word FA, FA means what? By default, we will construct an FA. Okay, and then we will try to convert it into DFA. If you are able to convert it into DFA easily, then no problem. Otherwise, we will use algorithm for NFA to DFA conversion, which will be our next topic according to syllabus. Let me show you the slide. Okay, let me show you the slide for the syllabus. So after construction, next topic itself will be NFA to DFA conversion. So don't worry if you are not able to catch up with me, that if you are not able to convert NFA to DFA, no problem. I will make you crystal clear all these things in the next subsequent class. That will be the, or you can say next subsequent topic, that will be the conversion of NFA to DFA. Okay, okay, so let's take first example, that is ending with something. Okay, so construction FA which accept all those strings over A and B which ends with A. Very simple case. See, end with A na. So let's take one final state, and after reading A we will move here. Now initially whatever we can read anything. Okay, we can read anything, and since we have strings over A and B, so sigma will be A comma B. Sigma will be A comma B. Okay, so you have to put A as well as B on every state. Okay, okay, so on Q0 we will have a self loop of A comma B. Why? Just because since we are saying ending with A, so on final state after reading A we will move to this final state. Okay, now initially whatever come we really don't care, so we will apply self loop of A comma B on Q0. So whether it comes A or B, we will keep on moving on Q0 itself, and as soon as the last A come, then we will move to this final state, that will be Q1. Okay, let me give you some examples. Say smallest string which ends with A is single A. So on Q0 there is a choice. We after reading A we can be at Q0 also, and we can move to Q1 also. So since we have only one A in the string, so we will move to Q1 and hence it will be accepted. What about my AB? ABA, or let me say it like this, BA. BA will be accepted or not? Yes, obviously on B it will be at Q0, and on A it will be moved to Q1. Okay, BAA, will it be accepted? Yes, BA will remain on Q0, and after reading the last A it will move to Q1. Okay, then ABA, again it will be accepted. Double BA, again accepted. ABA, this will be obviously accepted. Why? Because all these symbols will remain on Q0, and after reading the last A, it NFA will be at Q1 state. Okay, I hope I have made the point clear. This will be our NFA. Now how to convert it into DFA? Again, very simple case. See, the only problem here is, see, we have here three problems. First problem is on Q0 we have a choice of A. Okay, so on Q0, whenever A is read, then we can be at Q0 also, and we can move to Q1 also. We have a choice of A. And second thing, dead configuration. On Q1, we are not reading any A or any B. Okay, so we have to get rid of all these things. So this is very, very easy task. Okay, let me put it this way. Okay, let me again construct this NFA, and then I will convert it into DFA. So A comma B, A, and then Q1, this will be our final state. So first thing is, whenever at Q0 A is read, then we should move to Q1 or we should remain at Q0. See, the answer will be very simple. After reading A, we have to jump to final state now, because the string can be only single A also, and single A we have to accept. So you should not include this A here. Okay, so on reading for B, we will have a self loop. Okay, for B we will have a self loop, and for A we will not have self loop, rather A will move to Q1, because we do not need any choice now. You should be asking me first question that we have to delete either this A or this A. Okay, we have to remove this move or this move. We cannot remove this move because single A is accepted, so we have to keep this move, but this self loop move can be deleted from here. Okay, so now A and B, everything is completed for Q0. What about my Q1? Okay, so now do not worry about Q0, because A and B both are completed. What about my Q1? Q1A, where it will move? See, if you have single A, then I can have any number of A's and still string will end with A only. So A will be self loop. What about my B? See, if you have read A and we have read many A's, we are at Q1 only. As soon as we read B, then it is not ending with A. Rather, this string will be ending with B. So again, we need an A, so that string will be accepted. So on B, we will move here on Q0. Okay, okay, and as soon as we get one more A, we will jump to the final. Okay, so now please see all these things. A and B of every state is completed. Hence, this will be example of first class DFA. Okay, this is a first class DFA. Why? Because each and every state and each and every input combination, we have exactly one move. There is no choice and there is no dead configuration. On Q0, A and B move are defined properly. On Q1, A and B moves are defined properly. So this is your DFA. I hope I have made the point clear. If you are still not able to follow, please rewind the video and run it again and again and try to follow my points. Okay, and if still you have doubt, then no problem at all. I will clear I will clear all the doubts in subsequent lectures also. Okay, so I will keep on repeating the same thing again and again, so you will get each and everything. No problem about it. Okay, so please note it down. Let's move to next question. Ends with double A. Okay, so let me say you one thing also. If you are able to follow this, then please, for homework, you will make FA which ends with B. In homework, you will make FA ends with B. So I am not writing the proper question. Okay, the proper question will be like this: construct an FA which accepts all those strings over A and B which ends with B in place of A which ends with B. So you just have to make this B only. Okay, and you have to convert all these things. So this is very, very simple. I hope you can do it. If you are still not able to do it, please comment me. I will make this DFA also for you. NFA and DFA both I will make. Okay, now let's move to next, that is ends with double A. Ends with double A. Again, this is very, very simple. See, ends with double A means what? Again, same idea. This will be my final state. 1A, this will be your last state. Okay, and this will be your second last state. So we have a state in between state. Okay, and now see, if last two we have read two A's in the last, or you can say the string end with double A, then it will be obviously accepted. But before that, we can have anything, anything. So we will have a self loop of A comma B here. Okay, so now this is your first class NFA. NFA is ready. Okay, you can check it out. Smallest string will be double A. Double A will be obviously accepted. See, I can label these states Q0, Q1, and Q2. So at Q0, whenever double A is read, then no doubt we can remain on Q0 also, but we can move to Q1 also, and we can move to Q2 also. With double A, we can remain on Q0. With double A, we can remain on Q1 also. See, one A on Q0 and another A on Q1. With double A, if you do not use this self loop, then we can move to Q2 also. So since there is a path, so double A will be accepted. Okay, now what about my triple A? Obviously triple A will be accepted. Why? Because it is ending with double A. So how triple A will be accepted? One A on self loop, then double A will lead to final state. B double A obviously accepted, B self loop, then double A will lead to final state. Now let me say like this. So all these symbols will remain on the self loop, that is A, B, double B, triple A, B, and so on. Everything will remain here. Last two A's will lead to final state. Okay, so hence NFA is completed. Now let's convert it into DFA. Again, this is very simple case, very simple. Okay, just think about it. You will get your answer. Okay, let me put it this way. Let me make it again. Okay, or you can say let me take a different color for you. It will become more beautiful. Q0 is your initial state. Okay, and A comma B, A to Q1, A to Q2. Now what are the basic problems? Okay, that is, or I can say why this is not a DFA, because here we have dead configuration and here we have a choice of Q0 A on Q0 also and on Q1 also. So what should we do? So first thing is, since double A is accepted, so after on Q0 A will lead to Q1 and then this A will lead to Q2. So I can comfortably remove this A from self loop. Okay, so first thing I have made clear that A will be removed. Okay, so now think about it. On Q0 A and B already completed. On Q1 A is completed. What about my B? So see, if you want to take decision that B will go where, from Q, whenever at Q1 B is read, then B will move to either Q0, Q1, Q2, where it should go. Like see, should I make like this, B self loop, or I can move like this? Okay, or I can move like this. What should I do? Okay, so I have to take decision. This is very simple. Take example of string, you will get your answer. After reading A, see, you have read many B's and we have read A. If you have read many B's, then we will remain at Q0 only, and after reading A, we are at Q1. Whenever I get B here, then again I will be in search of double A. Then again I will be in search of double A, and double A search is completed from Q0 only. So at Q0, whenever double A is read, then we can move to Q2. Okay, so this B will move to here. I hope I have made the point crystal clear to all of you that on Q1, whenever B is read, then why we will move to Q0? Because on Q0, whenever double A is read, we will move to Q2. Na? So whenever, see, many B's are read and A is read, then we are at Q1. At Q1, whenever B is read, that means what? We are again in search of double A. Okay, so for searching double A, we should move to Q0 only. I hope I have made the point clear. Okay, now at Q2, so Q0, B and A is completed, Q1, A and B is completed, no problem at all. Now we have only one state remaining, that is Q2. Since that configuration is not allowed in DFA, so we have to take decision about A and B of Q2. Tell me something about A. Okay, so where A will go? On Q2, obviously we will have self loop of A. This is very easy. Why? Because after double A, we are at Q2. Again, we can read any number of A's. Okay, and the still string will be ending with double A only. Hence, A will be self loop. What about my B? Obviously, whenever we have read many A's, we are at Q2. And whenever one B is read, then again we are in search of double A. Na? So it will move here. Okay, I hope I have made the point clear. So ending with double A is over. Now for your homework, you will construct ending with double B. Ending with double B. Ending with double B is your homework. Okay, let's move to next question. This is your last question. Don't worry. Next category we will study in the next class. Okay, ending with AB. How to construct FA for ending with AB? See, again, very simple. On final state, last B will lead to our final state, and second last will be A, and here on initial state we can read anything, either A or B. This is very simple. I will make it a bit faster. Okay, and this will be your Q2 state now. This will be your Q2, which is your final. Okay, so so NFA is completed. I hope I do not need to give you an explanation for this. NFA is completed. You try to convert it into DFA. Why NFA is completed? I hope see, smallest string is AB, ending with AB is smallest string is AB. So AB will lead to Q2, है ना? So starting from initial state, A and B will lead to Q2. You can think that AB can be here also, but this will all be repetition. I have told you many times that there should be at least one path which lead us to final state. From initial state, there should be at least one path which lead to final state. So there is one path. That's why AB is accepted. Okay, so we can move AB here also, no? On Q note also, and AB here also, and A here and B here. So there are two possible paths for AB. One path is only Q note. Okay, let me repeat all these things so that everybody get crystal idea about these things. So Q note A, then you can remain on Q note, and on B you can also remain on Q note. This is one path. Another path is Q naught, then A will lead to Q1 and B will lead to Q2, and Q2 is our final state. So one path is leading us to final state, hence string will be accepted. Okay, so AB is accepted. Then what about my AAB? Again accepted. Why? Because 1A on self loop and AB ending with AB, so it will move to Q2. That is our final state. BAB again accepted, and B on the self loop, and the last AB will lead us to final state. Dot 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 dot. I hope I have made the point clear. So this is your NFA. Okay, and I should not give you this much detailed explanation because I have already given you explanation in the previous questions, but still I felt that since this is a recorded session, so some of you might not have got the proper idea. That's why I have given you a brief introduction. Okay, now let's convert it into DFA. Okay, so let's convert it into DFA. So Q naught, okay, A comma B, A Q1, A Q1, then B Q2. Q2 is our final state. Okay, so I hope now you have a good idea. So A will be removed from here. Okay, we will keep only B here. Why? Because AB is accepted. Now that's why. Okay, so B and A. So A and B both completed for Q naught. Q1 B is completed. What about A? So Q1 A, where this will go? This is very obvious. See, you have read many B's. You have read many B's, and then a single A. You are at Q1. At Q1, if you read more A's, and as soon as you get a B, then that string will be ending with AB or not. Hence, we will have a self loop of A here, because A, after reading A, you can read any number of A's, and as soon as you get B, that will be ending with AB only. So A will be self loop here. So for Q1, A and B both are completed, and for final state, we have to give you idea about where A and B will go, because that configuration is not allowed in DFA. So what about A here? Okay, on Q2, whenever A is read, then where it will go? See, after reading AB, you are at Q2. Whenever you read A, then you just need a B, single B, then this will be ending with AB. So A will move here. Okay, because immediately, see, Q1 need one B, then we will move to finals. Okay, so only one B. So need is only one B. So one B need is fulfilled by Q1 only. So whenever AB is read, let me repeat this point. Whenever AB is read, we are at Q2. Imagine we are at Q2, and whenever A is read, then we just need a B so that we move to final state. So this can be fulfilled, this need can be fulfilled by Q1 state. So on A, we will move to Q1. What about my B here? We are at, after reading AB, we are at Q2. Whenever a B came, then you need again AB, so that string will be accepted. So its B will move to initial state. Okay, I hope I have made this point clear. So even if you have a little bit doubt, these doubts will be cleared in subsequent lectures. No need to worry about all these things. Okay, so ending with AB I have cleared. So for homework, I will give you ending with BA. Ending with BA. Okay, please make NFA as well as DFA for ending with BA. NFA is very easy. You just have to convert it to DFA. Okay, this will make your thinking broader, and this is very easy question. You can easily design it. It will be just like similar only. I can give you a hint that A will just convert A move to B move and B move to A move. That's it. Okay, you will get your idea. Okay, so the next category is starting with something. I will be dealing with all these things in the next lecture. Okay, thank you so much. You can note it down all these things. Okay, in the next lecture we will study the next category of question, that is starting with something. Okay, bye bye.